Yes, good evening everyone. Please turn on your video before we start the class. Okay, fine. So, children, as we have done, what we have done in the last class, we have completed this theorem also, that is angles in the same segment of a circle are equal. This theorem, I will give you a quick revision of this. See, that is if you have two angles, suppose if this is the A and this is B, and this is the same arc, in this same arc, if these two angles have been inscribed, right, these two angles will be same. Why they both will be same? Because if this is the angle on the circle and this is the angle at the center, we know that this angle will be half of this angle, and similarly we know that this angle will also be half of this whole angle, right? That's why what we can say, if this is half of both the angles, then this both angles will be same. That is, this angle will be equal to this angle. We have done this proof in the last class, right? This was just a quick revision of that. Okay. Also, we know that the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. That is, if I draw, this is the center, and if I draw this lines, and if this is the angle, and if I draw on the same segment, if I draw another angle by which is touching the circle, then what happens? This angle will be half of this angle. Getting it? Yeah. This angle will be half of this angle. Similarly, even if I draw angle like this over here, this angle will also be half of this angle. Okay, that's what is the statement for this? The angle subtended by an arc at the center, the angle subtended by this arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Fine. These two theorems are clear, because based on these two theorems only we'll be doing the further exercise. Okay. And there is one more theorem remaining, I think. Just a moment. Yeah, the next one is the cyclic quadrilateral. Okay. The sum of either pair of opposite angles of a cyclic quadrilateral is always 180 degree. You don't have the proof of this. You only have the statement of this. Okay. The sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. Also, there is one more theorem. That's just the converse of that. If the sum of pair of opposite angles of a quadrilateral is 180 degree, then the quadrilateral is a cyclic. Now, did I told you what is cyclic quadrilateral? I think I have told you, but still I'll tell it to you again. If this is your circle, and if I draw any quadrilateral inside this circle, which where all the vertices are touching the uh, circumference of the circle, suppose this is one of the side, this is the other side, this is the let's say this is the other side, and this is the fourth side. Now, what we can say, the all the vertices of this quadrilateral are touching the circle. That's why this quadrilateral will be said as what? Cyclic quadrilateral. This quadrilateral will be what? It's a cyclic quadrilateral. It's a cyclic quadrilateral. Now, if it is a cyclic quadrilateral, then what do we know? That sum of opposite pairs of angles, suppose if this is A and this is B, then what we know, that is A plus B will always be 180 degree. You just keep it in mind. Okay, A plus B will always be 180 degree. Similarly, this angle plus this angle, if I say this is C and this is D, I know that C plus D is also always 180 degree whenever it's a cyclic quadrilateral. Is that clear? Yeah, everyone over here, please raise your hand if this is clear. It's a very simple thing. Yeah. Now further to this. Now we can start with the exercise which you have. The next exercise which you have is the exercise 10.5. We'll start with it. And this is the last exercise which you have for the chapter circles. Now over here is your the first sum which you have over here. Now in this exercise 10.5, in figure 10.36, A, B, C are 3 points on a circle with center O. These 3 points are there, and this O is the center of the circle. Fine. Such that angle BOC, they have given this angle BOC is how much? 30 degrees. And angle AOB is how much? 60 degrees. And if D is a point on the circle other than the arc ABC, then other than arc ABC, D is the other point, then you have to find what is angle EDC. Did you understood the question? Now what we need is angle ADC, right? This angle ADC is required. So how we can find? See, if this is 30, this is 60, can I say this whole angle is 90 degree? Angle AOC
Yes.
will be equal to 90 degree. Yeah. Also, angle ADC can be found very easily. That is, angle ADC will be what? Half of angle AOC. Why? Angle subtended by the same arc at the center is what? Double the double the angle which it subtends at the circle. The same theorem which we have just studied. Whichever it is, the theorem. Angle in the same. No, not this one. Yeah, the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Right? That's why what we can say, we have to write a statement over here, whatever the theorem states, that is angle subtended by the arc, by the same arc, by the same arc at the center is double the angle subtended at any point on the circle. Fine? This is the reason. So if you want what is angle ADC, that can be easily found. We know what is angle AOC, that is 90 degree. So half of 90 degree and that gives you 45 degree. Is that clear? Yes, everyone over here?
Yes.
Very simple. Okay. Now the
Yes.
next. The next questions which you have in your exercise is just a moment. The next question. A chord of a circle is equal to the radius of the circle. Find the angle subtended by the chord at the point on the minor arc and also at a point on the major arc. Okay, let's find this. What they said? A chord of a circle is equal to the radius of the circle. Fine. Let us draw one circle and let's draw the condition which they have given. What they said, that the chord of the circle is equal to the radius of the circle. Okay. I will draw a chord where the length of the chord should be equal to the radius of the chord. Radius of the circle. If this is the center of the circle, what they have given, all these distances are equal. See, we know that these two distances will be equal obviously because they are the radius. Okay, and this AB is also equal to OA. Why? Because it is equal to the radius. A chord of a circle is equal to the radius of the circle. Find the angle subtended, find the angle subtended by the chord at any point on the minor arc. Now, which is the minor arc? This is the minor arc. Now, angle subtended by this chord on the minor arc, it will be like this. If I draw the lines over here, the lines will be somewhere at any point on the minor arc. That means you need to find what is angle ADB. Yeah, you need to find what is angle ADB. And next, what they have given on the minor arc and also at a point on the major arc. Now, on the major arc means any point on this. So if I say this is that point, and if I draw lines over here, even if I draw it at that point, that is also right, just to avoid confusion, so that the diagram should be clear. That's why I've taken the point over there. Okay, even if you draw it over there, then also it is right. Now, what is required? You need to find what is angle ADB first. Okay, now we know that since OA is equals to OB is equals to AB, therefore triangle OAB is what? Is equilateral triangle. Therefore, can I say, therefore, angle AOB will be equal to how much?
60 degree.
60 degree. That's clear. Yeah. And if I say this is ACB, okay, if angle AOB is 60 degree, angle ACB will be how much?
30 degree.
Half of angle AOB. The reason is angle subtended at the center of the circle is double the angle subtended at any point on the circle. Angle subtended by the same arc at the center of the circle is double the angle subtended by the same arc at any other point on the circle. Fine. That's the reason you will write. I will not be writing that reason. That's a very big statement. That's why. Okay. So we can say half of angle AOB. AOB is how much? 60. Okay. So the answer comes as 30 degree. Angle ACB equals. Fine. Angle ACB is 30 degree. The next. Now what you need to find, you need to find what is angle ADB. That can be found very easily. We know that ACBD is a cyclic quadrilateral. Yeah.
Yes.
Yeah. Can we say that this is a cyclic quadrilateral? Since you can say quadrilateral ADBC is a cyclic quadrilateral, then what we can say? Therefore, angle ACD plus angle ADB should be how much?
180.
180 degree. What is the reason? Sum of opposite
Sir,
angle.
because cyclic quadrilaterals property.
Yeah, cyclic quadrilateral property. And what is that property? That is sum of opposite angles of a cyclic quadrilateral are 180 degree. Okay, you can write
Sir,
it.
how ACD?
Sorry, ACB. Yeah, the reason is sum of opposite angles of a cyclic quadrilateral. Sum of opposite angles of a cyclic quadrilateral are 180. Are supplementary, you can say. Yeah, we can also say they are supplementary. Now, as I know what is angle ACB, that is 30, will be equal to 180 degree. So that's it. I can say angle ADB is how much? 150 degree.
150.
150 degree.
Clear? That's it.
Yes.
Now the next. The next question is question number 3. Now what they have given in figure 10.37, angle PQR is 100 degree, where PQR are points on the circle with center O. You have to find angle OPR. They are asking you to find angle OPR. Now how we can find? Okay. Now since we can say, fine, I can draw what two lines over here. Okay, PQR, let's say PS, right? If I take any point S on this. So what I can say, quadrilateral PQRS is a cyclic quadrilateral. Yes or no? I can say that
Yes.
it's a cyclic quadrilateral. Now, once it's a cyclic quadrilateral, I know that
Sir,
angle,
how?
because I have drawn it. See, P, Q, R, S are touching the vertices of a circle. All the vertices are touching the circle.
Yes, sir.
So that's it. Then you can say it's a cyclic quadrilateral.
Yes, sir.
Yeah,
Understood.
understood. Now, angle PQR. We know that angle PQR plus angle PSR will be how much? 180 degree. Again, the same property. What is that property? Sum of angles in the cyclic quadrilateral, sum of opposite angles in a cyclic quadrilateral are supplementary. Yeah, the same reason you can write. Sum of, I will not write the statement, you can write it. Sum of opposite angles in a cyclic quadrilateral are supplementary. Now, since the sum of these two is 180, and I know one of them, that is 100, so I can get what is the other angle. So angle PSR will be 80 degree. Okay. I need what is angle POR, right? I know that angle POR, if I take this circle over here, if I take this circle over here, angle, wait, angle POR will be equal to half of angle, sorry, angle PSR, or you can also say angle POR is equals to twice of angle PSR. Yes or no? Angle at the
Yes.
center is always double the angle at any point, means the angle subtended by the same arc on the at the center is double the angle subtended by the same arc at any point at any other point on the circle. That's the statement you have to write. Okay, that's it. Then angle PSR is how much? 80, no? So 2 into 80, that gives you 160 degree. So angle POR is 160 degree. Is that clear, everyone?
Sir, but it asked OPR.
Sir, but is asking
Okay, okay,
OPR.
okay, okay. We can find that also. We have found what is POR. Now, again, if I take in this, if I take in triangle POR, in triangle POR, what I know, PO is equals to OR. What is the reason? Radius of the same circle. So can I say the triangle POR is an isosceles? Yeah. So
Yes.
I can also say that,
Yes,
yeah, I can also say that angle OPR plus is equal to angle ORP. What is the reason?
yes, sir. Sir,
Angle op
isosceles property.
yeah, angle opposite to same sides are equal. Yeah, angle
Yes.
opposite to equal sides are equal, or you can also say isosceles triangle property. Okay, you can write isosceles triangle property. Now, since these two angles are equal, now if I add, that is angle POR plus angle OPR plus angle ORP should be equal to 180 degree. Sum of interior angles of a triangle, yeah, should be equal to sum of,
Yes.
yeah, angle sum property of triangle. You can write angle sum property of triangle. Okay, I know that these two angles are equal. So can I say angle POR, whatever the angle is, that is 160, plus angle OPR, plus instead of this I can write again OPR equals
Yes,
180.
sir.
So twice of angle OPR will be equal to 180 minus 160, that is 20. So finally I can say therefore angle OPR will be how much? 10 degrees.
10.
Is that clear, everyone? Yeah?
Yes, sir.
Okay, the next question. Over here, in this, what you have, this angle is 69 and this angle is 30 degree, they said, right? So what I can say, in triangle ABC, what I know, angle ABC equals 69 degree, they have given. Angle ACB equals 31 degree, that is also given, right? So, okay, Riva, fine. So, angle ABC, we know that angle ABC plus angle ACB plus angle BAC will be equal to 180 degree. Yeah, it will be equal to 180 degree. So this, that is ABC, that is 69 plus 31 plus angle BAC is equals to 180 degree. So angle BAC will be equal to 180 minus 69 plus 31. Okay, so that is angle BAC will be equal to 180 minus this 9 plus 1 is 10, and this is 9 and then 10. So angle BAC is 80 degree. We got that this angle is 80 degree. Can I say angle BAC is equals to angle BDC? Yes, can I say that? Angle BAC is equals to angle BDC. Yes or no?
Yes, sir.
Why? What would be the reason?
Sir, because the triangles are of the same radius.
Yeah, these two angles are in the same segment. As you can see, this BC is the same arc, and these two angles are subtended by the same segment, no? Even if I draw any other segment, any other angle over here, that will also be equal. Okay? So what we can say over here, since angle BDC is equals to angle BAC, what is the reason? Angle subtended by the same segment. Angle subtended by the same segment. By the same segment. Therefore, what I can say, angle BDC will be equal to how much? 80 degree only. That's it. This is your final answer. And that's what is required. Is that clear to everyone? Please raise your hands if it is clear completely.
Yes.
Yeah. Please raise your hands, everyone over here. How many of you have understood everything clearly? Okay, everyone. Fine. You can lower down your hands. Next. Yes, done by anyone? Okay, I got answer from Shadan. Yeah, Shadan, your answer is right. Anyone of you, anyone else have solved it? Riva, okay. Yes, your also answer is also right. Fine. I will also solve this. What they have given over here in this, that is ABCD are 4 points. Okay, ABCD are 4 points on a circle. AC and BD intersect at point E. AC and BD intersect at point E such that angle BEC is this much. And angle ECD is 20 degree. You have to find what is angle BAC. You need to find what is this angle. Okay. If you want to find that, can I find this angle? This angle will be how much? If this is 130, because this BEC plus CED, since BD is a straight line, BEC plus CED should be equal to 180. So this angle has to be 50 degree, yes or no?
Yes.
Yeah. If this is 50 and this is 20, so this angle has to be how much? Sum of angles in a triangle is 180.
110.
Exactly. So this will be how much? 110 degrees. And if this is 110 degree, we can see that BDC and BAC are angles in the same segment. Therefore, angle
Yes.
BAC will be how much? 110 degrees. Understood, everyone? You have to write with all the reasons.
Yes.
Yeah? I hope everyone has understood this.
Yes.
Is there anyone who did not understood? Everyone has understood. Okay, if you have not understood, you can raise your hands. Fine. Now we'll go to the next. The next. The next question is question number 6. We'll do that. Now what they have given in this. ABCD is a cyclic quadrilateral whose diagonals intersect at point E, and if angle DBC is this and BAC is this, you have to find what is angle
Sir,
BCD.
can you show the diagram?
The diagram is not given in this. We have to draw the diagram.
Okay, sir.
Okay, let me check whether the diagram is given. Question number 6, no? Yeah, the diagram is not given. We have to draw the diagram. So what we can do, first we will draw the circle and then we will draw a cyclic quadrilateral into it. Okay, let's draw a cyclic quadrilateral inside. Okay, and if I say this is ABCD, now what they are saying, ABCD is a cyclic quadrilateral whose diagonal intersect at point E. If I draw diagonals to this, okay, this diagonals intersect at which point? The point is E. Okay, and if angle DBC is 70 degrees, okay, and angle BAC is 30 degrees, then find angle BCD. You have to find what is angle this. This angle you need to find. Okay. Further, if AB is equals to BC, then find angle ECB. That is a further thing that will consider this later on. First, you have to find what is angle BCD. How we can find. See, can I say, wait, yeah, can I say angle BAC is equals to angle BDC? Can I say this? What would be the property?
Sir,
Bro,
alternate
wait, wait,
angles.
wait. Dhruv, you don't answer. Yeah, anyone else, please answer. Ritika, can you answer why these two angles are equal? Yes. Riva,
Sir, can you repeat?
I'm saying that if this circle and the cyclic quadrilateral is given, and it is given that angle BAC, if I say that angle BAC is equals to angle BDC, can I say this?
Sir, alternate
What?
alternate.
No, alternate what? It's not alternate angles. These are angles in the same segment. You can see that this angle and this angle are in the same segment, are subtended by the same segment. Therefore, the two angles will be equal. Got it? Yeah. So what I can say, therefore, angle BDC is equals to how much? 30 degree. And the reason over here is angle subtended by same segment. Subtended by same segment. Angle subtended by same segment. Therefore, angle BDC will be equal to how much? 30 degree. So I can say that this angle will also be, angle will be 30 degree. Also, this is 30. Yeah, wait. Yeah, that's it. If this is 70 and this is 30, we know we can find this angle by using angle sum property in a triangle. Yes or no? Since,
Yes, sir.
yeah.
Yes.
So this angle will be how much? Angle DCB. Angle DCB will be equal to 180 minus 30 minus 70. That is, again, it's 80 degrees. The reason is angle sum property of triangle. Angle sum property of triangle. Is that clear? Yeah?
Can you
Yes.
Yeah? Yeah, what you are saying?
explain what I think?
This one?
No, sir, the upper one.
The upper one. See, this angle, see if you see this segment. See, I'll give you an example also. Wait, then I'll show it to you. If you have a circle and if you have a segment like this, okay? Now if you draw angles to this like this, suppose if you are drawing lines over here and here, or even if you take any other point, even if you take this point, now over here, all these angles will be equal. What is the reason? Angle subtended by the same segment. It is this, all angles are subtended by the same segment. Are you getting it? Yeah. All these angles are subtended by the same segment. That's why all these angles will be equal. Similarly, over here, this angle and this angle, both of them are subtended by the same segment. Can you see it? That's why the two angles will be equal. Did you got it?
Yes, sir.
Yeah. The one who had asked this question, that can you please explain
Sir,
it?
I.
Acha, Nandini, it was you. Fine. Understood, no? Yeah.
Yes, sir.
Okay, okay, fine. So that's it. And then we can say by angle sum property in triangle BDC, we can get that angle DCB will be equals to 80 degree. That's it. Okay. Now we'll go to the next question. Yeah. Can you try to solve this?
Sir, that one part was remaining.
Okay, acha, acha, yeah, right. One part is remaining. Yeah. Now further, if AB is equals to BC, then find angle ECB. Okay. Let me take this diagram first. Okay. Now what you have? ABCD is a cyclic quadrilateral whose diagonals intersect at point E, and this they have given. And now if AB is equals to BC, that means if this side is equals to this side, then find angle ECD. ECD. That means you this angle you need. That's very simple. See, if this is 30 and this side are equal, then this angle will be 30 degree. Isosceles triangle property. Yes or no? And what was angle
Yes.
DCB? That was 80. So this angle will
80,
be 50 degree. That's it. So
Fifth.
50.
angle ECD will be 50 degree. Is that clear?
Yes, sir.
Yeah. Okay. Fine.
Yes, sir.
Now, if diagonal diameter of the circle through the vertices of the, prove that it is a rectangle. Okay. Let's do the question number 7. Wait a moment. Okay, now what you have in this? If a diagonals of a cyclic quadrilateral are diameters of the circle through the vertices of the quadrilateral, prove that it is a rectangle. Fine. If I draw a circle, if I draw a circle like this, okay, and if the diagonals of a cyclic quadrilateral are diameter, that means there is a cyclic quadrilateral where the diagonals are diameters. That means if this is one of the diameter and this is one of the diameter, they both are what? Diagonals. Now what you have to prove? Through the vertices of the quadrilateral, prove that it is a rectangle. You have to prove that it will form a rectangle. Obviously, as you can see, even if I draw it, it forms a rectangle only. But you need to prove that it will be a rectangle. What we know that this, if this is ABCD, what we know AC and BD are diameters of the circle. What is given in this? What is given? AC and BD are diameters, and you can also say O is the center. O is the center of circle. Okay, this is O. Also, what you need to prove what you have. What do you have to prove? That quadrilateral ABCD is a rectangle. Yeah. Now, how we can prove that it is a rectangle? Okay. Wait. Let me take this diagram. Now, as per the diagram, since BOD is a straight line, so angle BOD will be equal to 180 degree. Yes or no? Yeah. An angle
Yes.
BAD will be equal to half of angle BOD. What is the reason? Angle subtended by this at the center of the circle is equals to double the angle subtended at any point on the circle. Yes or no? So can I say this is equals to half of angle BOD, that is half of 180 degree. So this is angle BAD is 90 degree. Similarly, I can say that ABC is also 90 degree and BCD is also 90 degree. Once three of the angles are 90 degree, the other angle has to be 90 degree and it will be a rectangle. Similarly, we can write similarly what I can say. Similarly, angle ABC is equals to angle BCD is equals to 90 degree. We can prove this. Therefore, what I can say, quadrilateral ABCD is a what? Rectangle. Understood, everyone?
Yes.
Yeah, everyone, is it clear? Okay, fine. The next question. The next is question number 8. Yeah, can you try this? Please try it on your own. Yes. Did anyone get it? How to do it? See what they have given in this. If the non-parallel sides of a trapezium are equal, that means we know what is the trapezium. How does it look? That is, there are two parallel sides to the trapezium and there are two non-parallel sides. They have given that the non-parallel sides are equal. That means it's a isosceles trapezium. We also say it as a isosceles trapezium. Okay, this side is equals to this side. They have already given. The non-parallel sides are equal. You have to prove that it is cyclic. If I say this is A, B, C, and D, what is given? What is given in this? AC is equals to BD. Oh wait, there is a mistake. Every time we have to write the vertices in a clockwise or in a anti-clockwise way. So if A B, this should be C and this should be D. We cannot write this as C and this as D. Okay. Now AC is equal, no, then your AD is equals to BC. That's what is given. Okay, AD is equals to BC. This is what is given. Also, we know that AB is parallel to DC. Also, AB is parallel to DC. This is what the given thing is because it's a quadrilateral. It's a trapezium. That's why. Now, what do you need to prove? To prove is quadrilateral ABCD is cyclic quadrilateral. Now, when it will be a cyclic quadrilateral, that means there is a circle which can be drawn through where it will touch all the vertices of a quadrilateral. Okay, so it is that kind of quadrilateral we need to prove. Now, when it will be a cyclic quadrilateral, when the opposite pair, the sum of opposite pairs is equals 180 degree, then we can say if any one opposite angles, sum of opposite angle is 180, then we can say that's a cyclic. Because if the sum of this two is 180, the sum of this two has to be 180. Because, are you getting it? If the sum of this two is 180, the sum of this two has to be 180. Because the sum of a quadrilateral is always 360 degree. Got it? So what we need to prove only is either this angle plus this angle is 180 degree, or you can say this angle plus this angle is 180 degree. If you prove that, then we can say the quadrilateral ABCD is a cyclic quadrilateral. Did you understood up to over here?
Yes,
Yeah?
Yes.
sir.
Yeah? Okay. Fine. Now we need to prove that the angle BAD, we need to prove that is this angle plus this angle is 180 degree. Okay, how we can prove? Suppose if I draw lines over here like this. Wait. Yeah. Suppose if I draw lines over here like this. Okay. If I'm drawing lines over here like this. This is ABCD, and let's say these points are E and F. Okay, this both the points are E and F. I have this. Now, uh, this side is equal to this side. Yeah, this is drawn 90 degree. Okay. Now, in triangle, in triangle AED and triangle BFC. Okay, in these two triangles. What I know, that is AD is equals to BC. This is by given. Yeah. AE will be equal to BF. What would be the reason? What would be the reason? Dhruv, you will not say. Anyone else? Why AE will be equal to BF?
Because they are parallel.
Because it is a distance between the parallel lines. Okay, it is the, we can say it's parallel, that's right, but you have to write it properly since distance between two parallel lines are equal, because this they are distance between parallel lines are equal. Okay, this is the reason. The next thing which we know is angle AED is equals to angle BFC, each 90 degree. Yeah, so this side and this angle, so the two triangles are congruent by which test? Therefore triangle AED, by which test? By which test? By which test? Anyone?
Sir, RHS test.
Yes, by RHS test of congruency. Okay, and if these two triangles are congruent, then what do you need to prove? Yeah, then can I say Angle ADE will be equal to BCF. Therefore,
Yes.
angle ADE is equals to angle BCF by CPCT. Let's say this as 1. Okay, let's say this as 1. Now, again, in the same this trapezium, in the same trapezium, I know that angle BAD plus angle ADC is equals to 180 degree. What is the reason? What is the reason?
Sum of adjacent interior angles is
Co-interior
supplementary.
angles. They are said as co-interior angles. Okay, sum of co-interior angles in a between the parallel lines are sum of co-interior angles will be equal to 180 degree. What you can say? Sum of co-interior
Co-interior angle.
angles between the parallel lines, between the parallel lines. Okay, the sum of these two are 180 degree. Yeah, but we already knew that ADC is equals to BCD from 1. ADE is equals to BCF. So instead of ADE, can I write BCF over here? So therefore,
Yes, sir.
if I say this is 2, I can say from 1 and 2, from 1 and 2, can I say angle BAD plus angle ADC, it is given, but you can also write BCF is equals to 180 degree. Therefore, I can say quadrilateral ABCD is a cyclic quadrilateral. If the sum of any two pair opposite angles are equals to 180 degree, then it will be a cyclic quadrilateral only. Yes or no? Everyone understood this? How many of you have understood? Please raise your hands. Yeah. Please try to solve the ninth problem by yourself first. Okay. Now see over here what they have given. First I'll explain. Two circles intersect at point B and C. There are two circles which they have given. These two circles are intersecting at B and C. Okay, these two circles are intersecting at B and C. Through B, two line segments ABD and PBQ are drawn. That means through B, they have drawn two lines like this. One is ABD and the other one is PBQ. Okay, are drawn to intersect the circles at point AD, ADPQ respectively. You have to prove that angle ACQ, ACP, that is ACP will be this angle is equals to angle QCD is equals to these two angles are equal. You need to prove this. Now we can prove. Fine. See over here. These are the 2 points which the circles are intersecting. Can I say angle PBA is equal to angle DBQ? Can I say this? What would be the reason? Dhruv, you will not say. What would be the reason? If PBA is equals to DBQ, what is the reason they both are equal?
Vertically opposite angles.
Yeah, perfect. They are vertically opposite angles. What we can say, they both are vertically opposite angles. Fine. Can I, let's write this as 1. Can I say angle PBA is equal to angle PCA? What would be the reason? Angle in the same segment. Yeah, what would be the reason? The reason is angle in the same segment. Let's write this as 2. Also, can I say angle DBQ is equals to angle DCQ?
Yes, sir.
Again, what would be the reason? Angle in the same segment.
Angle in
Same
the same
segment.
segment.
Angle in same segment again. And say if I say this has 3. So from 1, 2 and 3, what I can say? See, what we know that this angle is equal to this angle. We know that this angle is equal to this angle. And we also know that this angle is equal to this angle. So can I say these two angles are equal?
Yes, sir.
Yeah.
Yes.
So what we can say from 1, 2 and 3, from 1, 2 and 3, what I can say? Therefore, angle PCA is equals to angle DCQ, and you can say hence proved. Clear everyone?
Yes, sir.
It was simple or
Yes.
difficult?
Sir, it was simple.
Yeah, it was simple, but initially you thought it was hard, no? Yeah, it was simple, exactly. The next one. This was question number 9. Now let's solve question number 10. Now, if circles are drawn taking two sides of a triangle as diameter, if circles are drawn taking two sides of a triangle as diameter, okay, if I draw a triangle over here, let me draw the circles first, then it would be easy for me to draw. Okay, what they are saying, two circles are drawn taking two sides of a triangle, means that this is a diameter and this is also a diameter. Wait, yeah, what they have given, that if circles are drawn taking two sides of a triangle as diameter, means if these are the two sides of a triangle and this will be the third side, okay, and the circles are drawn, these two circles are drawn taking these two sides as the diameter, okay, prove that the point of intersection of these two circles lie on the third side. That means if I draw the third side of the triangle, what I can see, that the on the third side the point of intersection is also on the same point. Are you getting it? That's what we need to prove. Now how we can prove? If this is A, B, C, okay, fine. What we can say, hmm, yeah, if this is D, and if I join these two lines, these 2 points, okay, um, I need to prove. Yeah, what I can say, angle ADB will be how much? 90 degree. Why it will be 90 degree?
Sir, because AD is the altitude.
AB is the diameter, that's why. AD is not the altitude. Because AB is the
Sir,
diameter.
altitude of the triangle. AD.
No, no, I did not say that it is for altitude. I have just drawn it. We know that angle. Did I told you that angle in a semicircle are 90 degree?
No.
No, I did not explain you that. Fine, then we cannot use because that property is not there for you. Fine. If I say there is any other point, E. No, no, not required. Actually, no, this property is there for you. Angle ADB is equals to 90 degree. What is this property? That angle in a semicircle is always 90 degree. What is the property? Means if I draw, see, I'll explain you what is this exactly. If I draw any circle like this, if I draw any circle like this, and if I draw a diameter also to this, okay, and if I join any two sides now like this, suppose if I join this and this, or this, or this, if you take any point on the circle and join the two sides, what happens? It always gives you a 90 degree. What is 90 degree? This is always a 90 degree. You can take any two lines. Even if I draw lines over here, since it's a diameter, it will give you always 90 degree. If I join these two sides, it will always be 90 degree. Now, what is this property said as? Angle in a semicircle is always 90 degree. What is the property? Angle in a semicircle is always 90 degree. So that's why angle ADB will be equal to how much? 90 degree. What is the reason? Angle in semicircle. Angle in semicircle. Also, angle ADC is also equal to 90 degree. What is the reason? The same, angle in semicircle. Okay, angle in semicircle. Then what I can say? Then I can say that angle, since angle ADB plus angle ADC equals 180 degree, therefore B, D, C are on same line, and D is the point of intersection of the circle. Got it? D is a point of intersection of the circle. This D point will be there on the same line. Therefore, we can say that, therefore, this point D is on the third side of the triangle. Therefore, point D is on the third side of the triangle. Is that clear, everyone?
Yes, sir.
Yes, sir.
Yeah, that's fine. The next one. Now what you have over here, ABC and ADC are two right triangles with common hypotenuse AC. Prove that angle CAD and angle CBD are equal. Okay. ABC and ADC are two right triangles with common hypotenuse AC. Fine. If I draw this as one of the triangle ABC, which is a right angle triangle. Okay. This is A, B, and C. And what they said, ADC is also a right angle triangle with common hypotenuse AC. That means it is like this. Yeah, ADC. Prove that angle CAD is equals to angle CBD. Okay. We need to prove that this angle is equal to this angle. Now how we can prove that? It is already given that this angle is 90 and this angle is 90. Okay. Fine. If these two angles are 90 degree, they have given it. Okay. Now, yeah, what I can say, in triangle ABC, angle BAC plus angle BCA will be equal to 90 degree, because this angle is 90 degree, so the sum of these two angles will be 90 degree, yes or no? Yeah. Again,
Yes.
in triangle, if I say this is 1, again, in triangle ADC, I can say DAC, angle DAC plus angle DCA will be equal to 90 degree. The same reason, sum of interior angles of a triangle. Yeah, because this is 90. Now adding 1 and 2, adding 1 and 2, what you can do? Angle BAC plus angle DAC is plus angle BCA plus angle DCA is equals to 180 degree. Yes or no? But BAC plus DAC, BAC plus DAC. But wait, we do not know that the two lengths are equal. What I can say, angle BAC plus DAC will be angle BAD. Over here, what you have is angle BAC plus DAC. BAC plus DAC will be equal to angle BAD plus angle BCA plus DCA. BCA plus DCA can be written as angle BCD. equals 180 degree. Since the sum of opposite angles of a quadrilateral is equals to 180 degree, then what we can say, it's a cyclic quadrilateral. Therefore, quadrilateral
Yes.
ABCD is a cyclic quadrilateral. Yeah. If it's a cyclic quadrilateral, that means it is on the circle. Yeah. If I say this is my again the same kind of rectangle, and if I want to draw a circle, it's a cyclic quadrilateral, no? Over here it should be touching all the vertices, yes or no? So therefore, angle DAC will be equal to angle DBC by what property? Angles on the same chord or angles in the same segment?
Yes.
Angle in the same segment. And then what we can say? That these two angles are equal, and that's what is required. Angle CAD and angle CBD. That's what is required. Got it? Yeah, and
Yes, sir.
yeah, angles in
Yes,
the
sir.
same segment. That's it. Now the next and the last one which you have, prove that cyclic parallelogram is a rectangle. Means if I draw any parallelogram in a circle that will be a rectangle only. Now how do you know that? Fine. Well,
Sir, sir, we can say that the cyclic cyclic parallelogram needs to be the opposite sides the opposite angle to be equal, and it should be 180 degrees. So we can say that the opposite angles are 90 and rectangles is also 90 degrees.
yeah, almost. I think whatever you have said is almost right. What we can say over here, A, B, C, D. What is given in this? What is given? Quadrilateral ABCD is a parallelogram.
Cyclic parallelogram.
Yeah, is a cyclic parallelogram. Now, what is the definition of parallelogram? The only thing which we know in a parallelogram is the opposite sides are equal and the opposite sides are parallel. Okay. Now, if this side is parallel to this side and this side is parallel to this side, that's what we know. We need to prove that it's a rectangle. Now, how we can prove it's a rectangle? We know that opposite sum of opposite pairs. Wait, prove that cyclic parallelogram is rectangle. Okay, wait.
Sir, opposite angle on a parallelogram
Parallelogram are
needs to
equal.
be equal.
Are equal. Therefore, what we can say, angle A is equals to angle C. Yeah,
Yes,
angle
sir.
A plus angle C is equals to. They both will be equal because it's a cyclic parallelogram. It's a parallelogram. That's why. But since it's a cyclic, therefore angle A plus angle C should be equal to 180 degree.
180 degrees.
Yeah, we can also say angle A plus angle A is equals to 180 degree, and then twice of angle A will be equal to 180 degree, and then angle A will be equal to 90 degree. And now
90.
if any one angle in a parallelogram is 90 degree, then it is a rectangle. What we can say, if any one angle in a parallelogram is 90 degree, then it's a rectangle. Got it? Has to be a rectangle only, because if any one of the angle is 90 degree, then it will be a rectangle only. There is no other case is possible. Got it? Yeah, that's it
Yes, sir.
then.
Yes,
Over
sir.
here we are done with the chapter, and we are done with the class also, and in the next class we'll be starting with surface area and volume. Okay, I hope everyone has understood the
Okay,
chapter
sir.
circles. Yeah,
Yeah.
okay. Chalo then, bye bye everyone.
Bye, sir.
Yeah, bye bye everyone, have a good day.